Did it come on? All right, thank you. Destiny. Cosecant squared? No, but you're close. All right. That hurt. It's actually just cosine squared. Yep. We're doing this one for bell work because it's going to come up at the end of class and I want you to be ready for it. I'd like to spend the time to do this part together because the hard problem later on that also has this is just going to be demoralizing if we have to keep doing one struggle after another. So let me ask this while I try and figure out why this eraser is not working. Howard, pick somebody for me. They can't be at your table though. Oh, jeez. Oh, they can hear me say stuff. Jamil, do we have a binomial, trinomial, polynomial up there? What makes it a trinomial? Took a guess. Does anybody agree with them? I gotta disagree. Why did you say tri? There's three things, right? This is why I picked this problem. There's so many funny things happening here. This is a binomial, and the way we can tell is every time we have a plus or a minus sign, you just have one more than that. So one plus or minus sign, binomial means two terms. I have the term to the left, which is just cotangent squared, and then I have the term to the right, making this a binomial. There's no change. It just doesn't become a trinomial with the multiplication there. Jamil, pick somebody for me. Oh, and we'll answer Carissa's question.
So it's not to do with anything with the coefficient?
Nope, that doesn't matter. Yep. Or the exponent. That's degree. Go ahead. Who'd you pick? Howard. We have a binomial. We have the term on the left of the minus sign, the term on the right. Do they have anything in common?
Yes.
What do they have in common, sir?
The 2 and the cotangent.
Let's do the function. Yeah, they both have a cotangent, right?
Yes.
So let's pull that cotangent out. Howard, pick somebody to tell me what happens when I pull a cotangent out of a cotangent. Can't be at your table.
Let's go with Jamil.
Jamil, what's going to happen there when we pull that cotangent out?
We're pulling the cotangent on the left now?
Yes, sir. What's that going to leave behind on the left?
The x. Oh, no.
Oh, yeah. Careful. What holds its place, though? We're dividing a cotangent out. So what's cotangent squared divided by cotangent squared? There you go. Jamil, pick somebody to tell me what's left over on the right side. Howard, what's going to be left over on the right side?
So we're dividing cosine and cotangent, right?
We're dividing a cotangent squared x here. What's that going to leave behind?
Wait, so let me get this straight. It's cos squared.
It's cotangent squared x times cosine squared x. And now we're going to factor out a cotangent squared.
So would it be 1 and then?
Yep, that would be a 1 times cosine, right? I'm pulling this out. This is left behind.
Oh, wait. Oh, true. Yeah.
Now, if I had given you this problem instead.
Wait, why don't you divide it? Wouldn't you divide both of them?
Say it again.
Wait. Yeah, he did that. That was already out of it.
So if you guys are having a hard time seeing it, distribute this back in. What's cotangent squared times 1?
Cotangent squared.
And then I still have my minus sign. And then I do cotangent squared times cosine squared. And I'm right back where I started, right?
Yeah.
That's a good thing. That means I've done it right. Perfect. Who got this far? Honestly. All right, so pod 2 and 3 had a couple. Pod 3, majority. Jamil, let me just ask you in your gut, what is it telling you? In your gut, do you think we're done or do you think we got to keep going?
I hope we're done, but I think we're going to keep going.
Yeah, we're definitely going to keep going. This is the hard part. Well, for now. Did anybody make the next step? All right, Dwani, you look like you, like I said, had a crushing day. What did you do next? Let's lift your spirits. Did anybody else have any idea how in the world she got there? Yeah, she's saying just simplify this. And then we still have times cotangent. Now, someone's going to ask, wait, where did she get the sine squared from? I'm going to show you. Did you say that? Oh, really? You actually said that?
I said it.
Oh. It's been the question of the day.
Oh, it's like sine squared x minus cosine squared x equals 1. Right? And then you just like subtract.
That one, right? Remember, it's always plus there. Yeah.
Yeah. Oh, yeah, plus. Are you a mind reader?
No, it's just, this is the 4th time I've done this lesson, and I had that question 4 times. Well, it's not always she, it could be he, but
Yeah. I mean, I
Yeah.
don't look like a she, right?
no. Dwani's the she in this situation. You're the one who asked the question. Jillian. What did you use instead? Yeah, you can do that. You wouldn't want to worry about it from here. Oh, you divided at this point across?
I just divided cosine divided by
Cosine. Cosine divided by cotangent?
Like when you divide all of them.
Let me finish this and then I'll go over there and show you, because I don't think anybody else was going to go that route. Yes, sir.
Do you have a notebook?
Yeah, always in the second drawer. Take whatever you need, sir. All right, so Dwani told me 1 minus cosine squared was sine squared. Jamil gave me the Pythagorean identity. Can we do something to turn that in black into this? Well, it's 1 minus cosine, so what would we do? Yep. This is going to cancel these out and leaving me with sine squared x equals 1 minus cosine squared x. And now I have this here. I'm multiplying by 1. I can get rid of this. And I can see that this is equal to this, so I can make that substitution.
Oh wait, so that's just one of the rules?
Yeah, it's just it's a way to make this a lot nicer. Who answered who was picked last?
Me.
Okay, but we're skipping you because I called on Dwani, right? Who answered my last question? Dwani did. Dwani, who do you want to pick? You can pick Howard so he gets his turn back. Carissa, how can I rewrite cotangent in terms of sine and cosine? Say it again. Remember, there's 2 quotient identities, one for tangent, one for cotangent. That would give me tangent. That's the one. When we say quotient identity, you have 2 in there, sir. So cosine. Jamil, where are we going with this then, sir?
So now we have sine on both sides, which is good. So now we can put the 2 together.
Yep, and they're going to cancel out because
So we just get cosine. Wait, so.
Isn't there a way to do it?
Oh, so that's what I got.
to me this is easiest.
The one that's never the whole thing is just the answer.
Say it one more. Don't count on that. I'm going to show you that trick in a minute. We're going to go Jamil, Serene, Destiny. Go ahead.
In the beginning, I just subtracted cotangent squared minus cotangent squared, and I got the same answer. But is that just like lucky? Is that just
That's one of the things I wanted to talk to you about. You ever watch the cartoons where like they're trying to set the table and they trip and all this stuff goes in there, but it still lands perfectly on the table? That's what you just did. Is that ever going to happen again? No. I'm going to show you. You got so lucky there. That's why I chose this problem to talk about exactly that. I'm going to show you why it doesn't work. Who was next? Serene? Go ahead. No, not at all for this one. That's just me writing them that way right now because in calc we are writing them all day.
Sine or brackets doesn't matter.
No, not right now. Not for now. We're not talking about intervals here, so you're good. Destiny. This one here? Yeah. So, is it okay if I work in this direction? So right now I have cosines. I turned cotangent into this, and I had that already. So now I had sine. This is the same as sine over 1, right? So I'm going to go ahead and put it like that. And if I have to multiply these together now, right? Because that's what it's telling me with the bracket. So I can, let me do it this way so I don't have to keep rewriting it. This is cosine squared times sine squared over sine squared times 1. Meaning this is going to be cosine squared over times sine squared over sine squared. And since this is multiplication and this is division, these two will cancel, leaving me with cosine over 1, which is just cosine.
We've been working on
Yeah,
this
dude.
for 10 minutes.
Have we?
That's an equation, right?
Oh, if you can do it from your phone, yeah, go ahead.
That's an 11th grade equation.
Give me 1 second. Jillian. I'm going to do that one with you alone because I don't want to confuse everybody. But I do want to talk about what Jamil asked because that's one of those, just by the grace of whatever, you made it. But nothing else worked there. Any other questions, though, before I show you what Jamil asked and why it doesn't work? Okay.
Do you expect us to do this by ourselves? Yes.
Yeah. This is the 5.1 homework. This is one of the questions from there. 5.1 question 29, I had a couple people say we have no idea how to do it. I'll publish the solution for you on Canvas later today. Yeah, and that 29 seems to be pretty killer. All right. Thank you, sir. I'm going to approve his pass, and then I'm going to talk to you about what Jamil said he was going to do and why we can't do that. You're good, sir. All right. Right now, before we do this one, Jamil, I'm going to ask you this question. Let me say this. What would be the answer to that one? Now, what Jamil said is, why not just take this minus this, and bam, we got an answer. Wow. That's what you're asking, right? But now you see why. Yep, so we can't do that. We have to do the multiplication first before we can minus. Thank you. Oh, brackets. I thought it was BODMAS. Brackets, ordinals. No, it should be. Yeah, for ordinals. Maybe. All right. This is the only one I've seen. Don't worry about that one. That's for the cultured people, knowing that I've never left Tampa. Now, why can't we do this, Howard? No, don't worry about that. That should be erased from your memory. But explain to me why we can't subtract these two to get this. Because PEMDAS. And what does PEMDAS tell us? Perfect, that's exactly it. So this worked. It's like the cartoons. He tripped, but everything still landed on the plate.
It's like Peter Parker.
I don't know that one. Who's Peter Parker? All right. Now, keep this answer readily available because it's on our last problem today. Someone pointed out we've been doing this for like 10 minutes. That's because, and this is why I chose this as the bell work. That's okay. We have plenty of time today. It's not longer. It's getting used to that substitution. All right, let's visit this one. This one's been pretty funny. A lot of people are fumbling on this one.
Is it like really simple?
I think one thing I've been telling you guys since you were in my geometry class freshman year, if you were, is if this is hard to you, try and make it easier by going back to the basics, right? Let's say I have no idea how to do this. If I said m is equal to sine x, would you be able to find this?
Yeah.
Do you feel way more comfortable with what's on the board?
Yeah.
All right, so I tell you guys all the time, you don't want to be the smartest person in the room, and I'm always fortunate here. I would go to that while I'm learning this. So, no, I do it. You're good, sir. So, work this problem or this problem, whichever one you're more comfortable with, while I end his pass, and then I'll answer Destiny's question, and then we'll work on it. I just don't want to get him in trouble for being out too long. All right, Destiny, what's up? Say it again. That's the answer. Yep. All right, Howard. Howard, which one do you want to work on? Do you want to work on?
I'm working on the second one.
All right, what would you do first?
Oh.
You're trying to isolate M. What would you do first?
Yes. I don't know why. I tried to divide it, but you can't do that. So we add a little one.
There's nothing stopping you from dividing it first. It's just not conventional.
Wait, you can divide it?
You can do whatever you want. That's what I said. You don't. But let's go.
Multiply by 5.
Yes, it wouldn't change the answer. Howard, are we good so far? What's next? All right, so what does M equal here? Well, sine. If you're having trouble solving this one, go back to the basics, do a substitution, and go for it.
Why is your variable M?
Because in block 5, how long did we take to decide on a variable, Amelia? And then we ended up on smiley faces. It was, yeah. Serene, you had your hand up. Let me answer that. Ask what, if you got it right. We're going to do this now. Howard, pick somebody to talk me through this one. Jamil, what would I do first, sir?
Bro, is this one we just did? Oh,
It's-
we're just doing it like that way.
We're doing it the harder way, right? It looks harder, so
Sorry, but you just do the same thing, so just
yeah.
add one. And then after you add one, you're gonna have 2 sine x equals 1, then you just divide by 2, and then you just get 2 sine x equals 1.
I just wanted to show you that if you're struggling with this, make this substitution. You guys all will fly through this, and then you just substitute it back in at the end. It's just another way to approach it. Sine x is equal to 1/2. That's the beginning of our answer. So I'm going to move this over here. Oh yeah, there's so much more to do. All right. There's a bunch of questions that fall out from this. Number 1, what quadrant would this be in? I agree with Destiny. Destiny said the quadrant 1. How did you know, Destiny? Holy moly, she's giving me all the answers. So what she's saying is we know that sine of x is equal to 1/2. What value of x does sine equal 1/2 for? She said 30 degrees, it's in quadrant 1. Is there another answer though?
What's the gradient? Oh, wait, sorry.
Well, is there another quadrant it lies in?
I had a question. Can you explain that thing just one more time about the
Look how she did that?
Yeah.
Yeah, I'm going to do the whole thing in depth in just a minute. Well, let's do it now. She said the value is 1/2, right?
Yeah.
So she said knowing the unit circle at 30 degrees, we have some x value comma some y value, and sine is it. So that's going to be my next question. Now, Peter just got me with the next thing I was going to say. You guys may not like this. For the rest of the year, you cannot use degrees anymore. They're gone. Forget about them. You have to give me answers in radians. So, Peter, what did you say it was going to be? Does anyone disagree with Peter on that measurement for pi over 6? No, that's it. Thank you, Peter. So, huh? That one's the easiest one. You just do 180 divided by 30.
Yeah, but I memorized the entire unit.
Don't tell me that. You took like 8 tests on it.
Well, I did when I write it out, but it's not in my head.
Sarah. Just by going back to the unit circle and seeing that at 30 degrees sine or the y value is equal to positive 1/2. Duani.
Is it the fourth quadrant? Is your x coordinate positive?
Yes?
So can it be the x coordinate as well?
X is always cosine.
The fourth quadrant?
In all quadrants, x is your cosine value. Y is, so what other quadrant would y be positive? Aaron? Yeah. In the second quadrant, at what measurement, do you know?
It would be 5 pi over 6.
5 pi over 6 it is. Now,
So could you put either of those?
no, unfortunately you have to put both of those. And then we have to figure it out for every possible answer. And this is where it gets to be the pre-calc part of this. Now, let's revisit this really quick so we can get a faster way to do it. This is the all seniors take calculus. This means all trig functions are positive. Only sine is positive. Tangent's positive. Only cosine's positive. Now I had sine is positive, right? 1/2 is greater than 0. So it's going to have to be here and here. It can't be in these two because my y value is negative or below the x-axis. That's another way to think about it. Yeah. So going with all seniors take calculus or ASTC, here it tells me all are positive, and I can see that my y coordinate would have to be positive because I'm above the x-axis. If I come over here, I have a negative x, but sine doesn't relate to x, it relates to y. And since this is still above the x-axis, this is positive. Now it doesn't work here, because if I pick any point down here, this is going to be some x comma negative y, so sine won't be positive.
But then, so then tangent, the x and y are both there.
Perfect. And then and that would make it positive, and that's why I work. Yeah, Jamil, you got it. So here, tangent is y over x. This is negative y over negative x, making it positive. This is what we were struggling with last class, but I think it's starting to click. And then cosine's positive because here, going in this direction on the x-axis is positive. And sine's negative here because going down or below the x-axis makes my y-coordinate negative. So, in quadrant 2 is our second answer. If anyone is doubting either of these, put them in your calculator. Make sure you're in radians. And make sure you get back 1/2. Destiny, go ahead.
Is this like what the homework is going to look like?
Say that again.
Is this what the homework is going to
This is what your homework and your tests are going to look like. Yes, ma'am.
You're just looking for an end plot.
That we're about 2/3 to 1/2 of the way done now.
Don't you just need to look at circle it?
Yeah. Yeah, unit circle is your most valuable thing right now. Howard, yes, sir.
5/6, that's like 150, right? Degrees? But we're not supposed to use degrees, right?
Don't use degrees, but what is 5 pi over 6 in degrees? 150. There you go, Howard, thank you.
Oh, how do you know it's
But how would
exactly
you know
there?
which degree to go to?
Yeah, how do you know that?
Isn't
Just
it,
by the
what you call it? Not subtract. You add,
2.
yeah.
Yeah. Oh, for these two?
No, like you get, isn't it, it's some type of, it's not adjacent, it's like,
Coterminal?
yeah.
Yep, that's what we're going to be talking about. All right, Destiny already knows what we're doing. She's already got the end in sight. What's up, Jamil?
So I have a quick question. So like, let's say like that same question's on our quiz. Is it like, is it gonna say like find what quadrant it's in or like?
You don't have to do that. It makes it easier to know you're right, though.
Oh, okay. So
We
like, the quadrants aren't the answer. It's just like helping us like stay on track.
help us stay on track. Yep, that's it. This is the map to. We're not quite done yet. I heard my name somewhere. No. Yes.
How do you use this type of problem in the real world? I'm legitimately wondering. Like, I think of my
Let's say, Carson, you need to.
Like this exact type of problem?
yeah, or something similar to it. Or
Right.
we would have to use this now.
What are you going to study in college?
Like biology.
Okay, I can answer that for you. Just give me a minute. Let me show you the whole thing, and then I'll show you where it works.
There's a giant circle. You need to find, and let's say you're finding a friend, and she gives you this coordinates exactly. You need to find.
All right. Howard, we know that this solves to sine x equals 1/2, and these two, when plugged in for x, gives me 1/2, right?
I think so.
No, you got to know so.
Those are the quadrant we're going to, right?
Yes, sir. Those are.
Yeah.
All right.
And then
That's.
Give you 1/2.
Say it again.
5 pi over 6. Why would that give you 1/2?
the best example.
Do you have your calculator on you?
Plug that in.
Yeah, plug it in and check it, and then look at your unit. Do you have one of your unit circles that we did? Check at 5 pi over 6 and see what the y value is there, and then they should both agree. Now,
Wait, how do
How to do what, sir? How did I find, well, how did you know it was 30 right off the bat?
Because of 1/2.
Yeah, so you knew that if I gave you 30 degrees, right here would be,
No, I'm talking about the other one. 5/6.
that's what I'm going to show you here. So I'm going to make sure I'm talking what you did first, and then we're going to make it equal.
I know that.
Yeah, you knew this was the y for 5/6, right?
Now this,
But that's from your memory.
yeah. And the other one's that.
The other one,
50, now this way is from 30.
that is way different from 30, except for if I go to this, what's this in degrees? 180, right?
Wait.
Like at the x-axis, this is 180. Now you see how here I went from the x-axis up 30 degrees? Here I'm going from the x-axis up 30 degrees.
Oh,
The problem is I've got,
and then 270, 30, and
yeah.
then 360, 30.
Yep, so this is 90 here, right? And then
No, that's what,
this would be 90.
that's 150. That's 150.
It is because these two together, yeah. That's it.
And what's it called? 270 minus 30. And the next one is 360.
That's it, yeah. All right, Peter's slowly building the final answer. Now, here's everything we did, but we're skipping. And here's what that graph would look like.
Is that us like the sine graph?
This is the graph of the parent function sine x.
Because it goes to the x-axis.
And we solved for this in the form of the parent function, right? We found sine of x equals 1/2, and we got x equals say it again, sir. Over there? That's what we're slowly working towards. This problem is going to take a while.
How do you know it hits 1? How do you know it hits 1 with the y? It hits 1 and negative 1. How do you know that?
I'm going to ask you all of that. But talk about it together for just a minute. Dwani, question? Huh? Yeah, this is still the same problem. We're about halfway done now. Yep, that we're right on track. This class is going to take a difficulty ramp up right now. Oh yeah. On the 31st, you have your next test, topic 5. And then that next Monday, you're going to have the topic 6 test. We're doing the entire topic 6 Wednesday and Friday. Destiny, go ahead.
When did you say this test?
The 31st of January is a Monday.
But you said you would change it.
Do you guys want to change? Well, then that's why I'm bringing it up now. If I change it, that means you have to learn 6.1 and 6.2 before the topic 5 test, and then the next Monday take the test on it. Are you okay with that?
Wait, can we have it on Wednesday? Can we ever test on Wednesday?
You can have the topic 5 on Wednesday, but if you do that, then you're going to learn pretty much everything on the topic 6 test before you even take the topic 5 test.
Okay, Monday's okay.
Yeah, Monday's
I'm asking,
When is our review date? It's gonna be
what is our test date? We're deciding that now.
No, the review date.
The Friday before. For topic 5, Dewani? For topic 5, it'll be next Wednesday. The review. There's no quizzes. No notes. Let me pull up the calendar and I'll show you everything.
Okay, so you're saying topic 5 test, January 31st.
Yep.
Topic 6 test.
The next Monday. So the 31st is a Monday,
So when would we be starting topic 6?
Wednesday and Friday. There's only 3 sections in it. And you've seen 2 of the 3 already.
So would we be learning topic 6 before we take the topic 5
If you guys
test?
vote to take it on Wednesday, yes.
So if we take it on Monday, then that won't happen.
That will not happen. That's why I want you guys to be informed before you make the decision.
She put like an A for O. 'Cause
Let me think. I got an idea for you, Peter. Give me 1 second. Let me pull up the calendar so we're making informed decisions. I would definitely copy this. Let me show you the schedule first really quick.
Pi over 6, I'm sorry, pi over 6 minus 2 pi.
We're going to talk about all of that before we leave. So we finished this class pretty early. We're done with this class at the end of this quarter. You guys have learned all of pre-calc in one semester effectively.
So can we start like calc?
Yeah, quarter 4 is all calc.
Ooh, that's
Because there's,
scary. Does that mean we get tests for grade because it's not technically?
no, they have to be graded. Actually, some of the calc is on your required learning. So where are we at today? We are right here. On Friday, we have 5.4. Next Monday, we do 5.5. On next Wednesday, we're going to go over part 3 of the project, and I'm going to hand out your review. That you're going to work on it on Wednesday, and then Friday when you come in, it's any questions you have about the project or the review will go together. And this is what we're voting on right here. If I move this test to here, then you have to learn pretty much all of topic 6, take a test, learn another thing, and then take a test again.
No, we take topic 5 first.
Duani, you keep it?
Yeah.
All right.
Can you go back to today really quickly?
Uh-huh. These I made sure were on Canvas today. So we're in agreement. Keep the schedule as it is? Okay. So since you guys are going to do that, but you hate test on Monday, I'm going to let Peter send me a message that says what he wants on a cheat sheet. I will make it, and I will put it on your desk for everything I approve when you come in.
Can he make it everything?
I'm going to pick off of what he wants, what makes it. If he want whatever, Peter, if you put a unit circle, you'll get a unit circle.
There you go. Okay, pretty much.
I mostly just need like the whole.
Yeah, you send me what you want, and I'll put everything I approve on it. So thank Peter for a second here, guys, for asking. All right.
I love you. Yeah, I'm gonna thank you for this. Peter, I love you.
He can try. If he has the answers, though, we got a bigger problem. All right. 6.1 and 6.2 you guys saw in geometry, right? Law of sines and cosines.
Yeah, we've seen that.
Have you guys worked with vectors before? Where?
Wasn't it algebra or geometry?
Physics.
I've seen vectors before.
You guys have all seen vectors in a translation in geometry. Remember it had the weird brackets? And I kind of said those were vector, and I said, wait 2 years and I'll show you. That's that. And then we have a test on these three topics right here. Then we get into really what is just the algebra of the class. And then we have our topic 9 test. And then these, I know I'm being recorded right now, but realistically, nobody wants to do anything the week before spring break, right? So you're just going to present your project. You're going to get 6 minutes to come up and present. Amelia, you can do it in block 5 if you want. You're going to pick 1 or 2 problems, just take up 5 minutes. And then I'm going to put those in as presentation points. I'm not. All right, if you guys want, we can start calculus right before spring.
Yes. No. Yes. 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 Yes.
Because if we have a first line,
I don't want to show you a week of calculus and then you forget everything.
I'm going to be sending you the SAT session.
Individual. Huh? No, because your questions are all going to be different.
if you were to make a cheat sheet for this class, what would you put?
For this test right here,
Because like I know I'm already gonna put like the sign if it's over H and stuff like that.
have that.
Can I do the identities or no?
Put them on there. I'll look it over. I'll put what I can put on it. I'll say this, shoot for the moon.
Actually no, because you taught me the one thing. I forgot what it's called when you just divide by sine or cosine.
And get it over with, yeah. Destiny. Okay?
So, you guys are talking about presentations, right? So we could have 2 options. We could have a class presentation and then a private video presentation.
Actually, that's what I was going to ask you guys. If you don't want to be in front of the class, you can record your presentation, but we're just going to watch it. So I'll put it up here. Now, I will let you leave while your video's on. Or you can get a bathroom pass and just go. That's fine.
Are you still doing that thing advertising?
Yes, sir. right, finish copying this so we can talk about it. We'll worry more about the presentation part when it gets closer to us. Amelia, what's the big scare of talking in front of everybody? Yeah. If you record the video, you can go to the bathroom while it's on.
No, because then you come back to the bathroom and it's like,
I know, it makes it worse, trust me. What was her suggestion? You're going to forget everything. Do you want me to pull up Nate's freshman year where we look at him doing a spaghetti project? You'll what?
I said I would gladly do that.
The spaghetti project, or look at your video of you and John?
Both of them.
I'll give you about 2 more minutes to finish copying this. All right, you remember the spaghetti challenge, if you were in my geometry? Nate's group decided to take a desk and put it on top of another desk, then build their tower. No. Well, because I allowed that, someone else was sticking marshmallows to the wall. And then that was Joe.
That was Joe.
Yeah.
Because Joe can jump all the way to the top.
Yeah, Joe was jumping and slapping. So those were disqualified.
Wait, so the rule was you got the tallest marshmallow, right?
Tower, yeah.
Tower, wait, so this should like the marshmallow.
No.
If the marshmallow is there,
I did, but they didn't listen, so that's why I didn't win.
because there are people that completely cry about it. They're mad about losing. There was a 2-year review period.
Why is it?
Yes, ma'am. Yeah.
Because I want to get like an accurate.
Drawing it. Yeah, definitely. And on your tablet, you can even just take a screenshot and bring it in. Yep.
Wait, were you guys in the same group?
All right, Howard. We'll do this. If you really don't want to do the presentation, you can talk about why you should have won. I don't know. We'll figure it out. Don't panic.
Why you didn't do it? Like give a presentation on why.
Yeah, 6-minute presentation on why you didn't do it.
Yes, do it.
We'll figure it out. But for now, let's go back to this so we don't run out of time.
I refuse to do a presentation.
All right. Howard, pick somebody. Whoever you want. Not at your table. They can't be at your table.
No, I want to go.
Well, you'll be next then.
What if I phone a friend and then do something?
Just pick somebody, man. It's like,
Let's go, Jamil, I guess.
all right, Jamil. For this is my input, this is my output, right? 1/2. So this dotted line represents when we have y equals 1/2, or my output's 1/2, right? Every time my sine wave and 1/2 intersect, I have a solution, but I only found 2. How many do we see on the board right now?
3, 4,
5, 6. We have 3 maximums, and on each side of the maximum there's 2, so 3 times 2 is 6. Jamil, pick somebody. Howard. What is the domain of the sine function? How far to the left will it go? How far to the right will that graph go? Yeah. So what's the smallest value it'll approach? Going left, how small will it get?
Negative?
And going this way?
Positive. Or just positive. And just infinite.
All right. So Howard, pick somebody.
Let's go Jamil.
Jamil. We know it's going to go all the way on forever in both directions, right? And every time we hit a maximum, we're going to have 2 solutions. If it goes that way forever and this way forever, how many maximums are we going to have? It's going to be an infinite number, right? So how many solutions do I have? Do you guys think it would be fair if I told you to write every single one down? No. Destiny.
Why would the maximums be? What maximum?
The maximum is where it turns around. And every time I have a maximum, I get 2 solutions.
You mean the number of maximums?
The number of maximums, yeah. is infinite, and every maximum generates two answers, two solutions. So there's an infinite number of solutions here.
The max for sine is 1 though, right?
Yep.
So you're just saying the highest points, there's an infinite number of the shapes.
There's an infinite number of these shapes, and every time this shape turns around above the x-axis, this line will touch it twice. And if there's an infinite,
Talking about the maximum 1/2 line?
no, one, where the maximum is where it turns around. The amplitude. At every amplitude, I generate two solutions. Because 1/2 is less than 1, it has to touch both sides. I'm just saying the solutions are infinite.
And what would the range be then? Would it
Well-
just be -1 to +1?
Okay, the next question, Jamil, I guess you get to pick somebody, right? Or did you pick Howard already?
No, I think
Who cares? Jamil, pick somebody. Howard, what is the period of sine?
so. Period is like.
Period is how long until it starts over? One cycle.
Oh, so is it? No, it's not. Is it? No.
Nope.
Wait, because it starts there. Oh, so that's. Oh yeah, 2 pi. Yes.
All right, 2 pi is how long it takes to create a full circle, right?
Yeah. Yes.
Perfect. So, every period has one positive amplitude, one negative amplitude. So that means at pi over 6 was my first answer, 5 pi over 6. Then it starts over. So this is just pi over 6 plus the one full rotation. This is 5 pi over 6 plus the full rotation, right? So, do you think, or I'm not going to give you, what do you think the next rotation would be? What number would go right here? Alyssa, go for it. No, you're good. The first one, pi over 6, or 5 pi over 6 was 0 pi, right? Alyssa, the first one I had 5 pi over 6 with no other thing, right? So think of it as plus 0 pi. Then I got plus 2 pi. What's next in the pattern? Add one more rotation to it. Okay, Alyssa, pick somebody to tell me the answer. Jamil, what did you get?
So don't you just add 2 pi since that's what
Yep, one full rotation. So I get 4 pi. That's going to go on forever again, right? Destiny, go ahead.
Wait. So instead of changing the first number, you just adding pi?
Yeah, one more full. We're just finding a next coterminal angle.
Is that just the way it is for that graph, or could it turn into, you could add 2 pi to 5 pi over 6, and then make that the number, and then add another 2 pi?
You can do that too if you want, yeah. We're just adding one full rotation at a time. This, if I go here and I add 2 pi, it's going to end up here. If I add another 2 pi, it's going to be at 4 pi, but it's still going to be a solution. Go ahead.
Do we ever get a problem where it's like, what will this be in 60 rotations?
Yes. You're not going to want to do that right now. But what we're slowly easing our way towards is called a general solution. And that is, if I say, what would it be at 60 rotations, you're going to generate a function that will tell you right away. We're almost done with this problem. Now, someone asked me, I think it might have been Destiny, why do we have a minus 2 pi here? Jamil, without picking Howard, pick somebody in the room to tell me why they think I went from pi 6 to pi 6 minus 2 pi. Not you, sir, but pick somebody. Peter, why would it be minus 2 pi now? Yeah, it's just going backwards, right? But it's still one more circle. So what would be next? Minus 4 pi, minus 6 pi. Now, we've already said it would be unfair for me to ask you to write every solution since there's an infinite number of solutions. This would be just as unfair, right? You would spend the rest of your life. We have to come up with a way to write this where we can find it at any time. A general solution. Destiny.
Pi over 6 is on the top, and the 5 pi over 6 is on the bottom.
It's not. It's showing you it's up here. It's just for the ease of reading. So 5 pi over 6 is still on the top.
Those pi over 6, 5 pi
Say it one more time about the infinity.
It goes pi over 6 and then pi over 6 alternating toward this.
Yes. All right. So everything we still need is on the board. We know the domain is going from left to right, negative to positive infinity. Every 2 pi, we're going to get a new set of solutions. And the general, or the base solutions are pi over 6 plus pi over 6. And what we just said was, for solution 1, we know it's going to be pi over 6 plus 2 pi for 1, right? I'm just going to do this. If I'm going to slap down n as a variable, what do you think n's going to represent here? Yeah, the number of rotations. That's it. Destiny then asked, "What if would we ever be asked for 60?" Well, yeah. What if n was 60? What would our answer be?
125.
That makes it so much easier. Now you're not spending the rest of your life answering question 1 while the other 39 are getting you an F, right? Now we're just going to say we had pi over 6 as our first solution, and then we're adding a rotation this number of times. If n was 60, it would just be 2 pi times 60. It would be 120 pi. Now, there's one last thing we have to do to Thimble proof this. You guys spend all this time coming up with this, and then Thimble comes along and goes, oh. No. And don't make that voice for me again. No, I'm just kidding. No matter how accurate it is. All right. I come in here and I say n is equal to 1/2, and I'm checking your work. Did I just ruin everything you did? What is this? Yeah, that's just pi over 6 plus pi. We're at half a rotation, so now we're in trouble. That's not a solution, is it?
So you can't use fractions?
Yes, and we have to tell our reader that. And this is where you guys are. All right. So what kind of numbers can we use here?
Whole numbers.
All right, you guys said whole numbers. I'm going to show you the symbol for them. What are the whole numbers, guys?
1, 2, all of them.
That's the naturals.
0, 1, 2, 3.
0, 1, 2, 3. Numbers that are
Beautiful. Does that work if I plug in 2? I get 4 pi. That looks great. How do I get this one out of a whole number, though? There's no negatives. I can't get a minus sign, can I? Whole numbers aren't going to work. What did you just say? The integer sign is this, and we have to start putting this on our work now.
Z with an extra line.
Yep.
Wait, so what does that mean?
This is the integers.
What was it?
Integers.
Oh,
It's the whole numbers. The way I remember it, it's the whole numbers reflected over itself. So like 1 flips over and becomes -1, 2 flips over and becomes -2. That gives me the integers. All I have to add right now is that n is an element of the integers. And if you had me for geometry and I made you do all of this and you forgot about it right away because you said I'm never actually going to use this, this is why we started talking about those symbols and how to type them up. Now, huh? Who did you have? Dang. Oh, that's why. Okay.
We had a teacher last year. That's great.
All right. So right now, if I come in here and read this and I say, oh, Peter told me solution 1 is pi over 6 plus 2 pi times n, and I put in 1/2 and I mark him wrong, he's going to come up and say, Thimble, 1/2 is not an integer. What are you doing? Right? I made a mistake. I have to put an integer in here. Read this as n but I don't want to write that every time, so I'm going to write it like that. Put that for now every time. Tell me it can't be a fraction. Yes. Destiny. Huh? You have to do that, yeah. Yeah, it's a little funny.
So it just means it belongs to the.
The correct way to say it is element of or is in. But someone said n belongs to the integers, and that was much easier to remember.
it's not supposed to be a fraction. Right?
Are you asking? Oh, you're saying I can't make this 1/2 because of
I
that?
know what you're saying, but like, how would you write it out?
For the 1/2?
Yeah.
We leave it like that. That's telling me that the output has to be 1/2. We don't need, these are separate. This is the wave we're using.
So I'm saying, what if it was
Like 2/3
6 minus 1/2? What would you
pi over 6
minus 1/2?
minus 1/2 wouldn't put me, it would put me somewhere outside of it.
I mean, mom, 1/2.
But you want it to be like -2, right? Like you want to know how to generate this one?
No, like a period, because you know you said fractions can't work for anything.
Oh, for this one, yeah. If the period makes it a fraction, you can't have one. I'm not doing that to you guys. Still put the NZ for now. Yep. All right, what I want you guys to do, and I'm just going to have you bring it up one at a time in the next 5 minutes, is make solution number 2 for me. Wait, this can't be any easier. It's 5 pi over 6. It still has the same period. It still has the same domain. So it's going to have the same solution except for one thing is going to change. Jillian?
I can just change the variable.
Go ahead.
Change the n.
Yeah. Did you just... Can I see it? Where are we at? Yeah, Jillian's done. 5 minutes was very generous. Where are we at? All right, Destiny's done as well. I'm going to go ahead and say Damien's done without looking. Yeah, that's it.
What are you going to do my question?
When they all get up for their phones, we'll go over it.
Just what's the second solution? It's so
Oh, no, what did you get? Oh, yeah.
After this, is this when we do the homework?
Yep.
Wait, or
Just don't forget that n is an element of the integers. Yes. Where did the 2 come from? The answer, yep.
6, and then, so we have pi over 6, we just have 2 pi, right? So I
Yeah,
need to-
but so that was our first solution.
Oh,
We said the other answer was 5 pi over 6.
okay.
It's going to look exactly the same except for where pi over 6 is. Just make it 5 pi over 6.
Oh, okay.
That's all. All right, I'm not going to... Go ahead. I'll check yours last. What's that last thing there? No, the 2 pi 5?
why is it 5? Because I simplified it in. This is the actual thing.
Yeah, just keep an n there instead of 5, so it's for any possible integer. That's just the one she chose. It's actually, so are you, were you pretty okay with this part? It's just asking you to do the next part? So, all right, here we go. My first one was pi over 6 plus 1 full rotation any number of times. And I can see that this follows the same with 5 pi over 6. So this part's never going to change. That's 1 more full rotation n number of times. N is still an integer. And then I had pi over 6 here. That was my first solution. My second solution is only different in that we have 5 pi over 6. So that's my second solution. All you have to do is memorize this part for cosine and sine, and then slap your solutions in front. Those are the solutions for everyone. Destiny. There are only 2 solutions for this one, yes. Always do that, yes.
Technically, pi over 6 and 5 pi over 6 would also be the number 2, but it's not the same thing.
Well, pi over 6, yeah, if I say n is 0, it is. And n being 0 is fine with the integer, so that's fine. Yeah, it works for everything. Destiny and then Yvonne. This part's the same for cosine, yes ma'am. We just put, and we put our solutions here for, yeah, cosine is exactly the same process. Yes, same general formula. Say it again. Solution. Good afternoon.
Hey, can I get Sarah to come on, please?
She is on her way, thank you. All right. I am going to leave this one for you guys. We did all of this together. Here's your first homework. The rest of the class is homework questions. We're doing homework now. So, I knew somebody was going to ask that next. Did we just do this though? Really? It was a minus sign last time. Let's see how the answers change. I'll give you guys a few minutes, then we'll do it together. This is the first, yeah, this is part of the homework. So if you guys want to get a new sheet of paper, put your name on top, and then put in class homework. And then like do 29. And then when we leave, just draw a line under it and put at home. You don't have to do 2 sheets of paper. You don't have to do it again. Just mark the ones we got done in class so I can see which block got the furthest.
So we got 5 pi over 6.
Yes, sir.
Plus 2 pi.
So that's one more. So I think it's easier. Like we know 5 pi over 6 is right here. So if I went, that's my first answer, right? If I go a full circle, that's 2 pi. So now I have 5 pi here plus 2 pi. And then I can just keep doing that over and over forever.
So after we get right there, that just
Yeah, you just have to put the n at the end of that and you're done. For the number of times you've rotated. That's it.
Do we just have to solve for sine, or do we have to do all of it?
Give me the, thank you. Yeah, do e-hall pass and I'll approve you.
I don't know my login is. It's already set up on my phone.
Go for your phone, sir. Yeah. Go all the way to the end. Yep. Your last answer should be something n as an element of the integers.
How did you know the period was 2 pi?
The parent function. Right, sine by, so you're going to get sine x equals negative, and we know the period of sine is 2 pi. Yep.
So the period's gonna be 2. But
Yes, sir. Will they get harder later? Maybe, not really. But for now, sine is always 2 pi.
E? What does the E represent?
Where, sir?
N-E-Z?
N is an element of the integers.
Element?
Yep. We're going to have to do a homework on some of these symbols.
Is this correct? Is the whole thing
Stop saying that.
Yep.
okay?
We have a couple right answers. Let me get this for you, sir. Did it go through?
Yeah.
Oh man, I got a couple I may have ignored. Whoops. Or did you send it twice?
Oh, maybe I did.
That's all good. You're on your way, sir.
All right, thank you.
Yes, sir. Hey, when you get back, just remind me to end it so they don't. I always forget. Huh? No, you can go, now you can go straight to your answer. Find the 2 solutions and then do plus 2 pi n as an element of the. No, I want to show you every step. I want you guys to take. Exactly, yep. Give me 1 second, Destiny. I just got to make sure I took attendance. Howard, go ahead. I'll listen while I look at attendance.
So I was just saying, so do I just add negative 1/2 to this equation? That's it or no?
I wish it was that easy. You need to go to your unit circle
Okay.
and see when does sine of x equal negative 1/2.
Negative 1/2. So it's
And then you add
it's
that.
Be below because it's negative.
Both, yes, sir.
So it's going to be both quadrant 3 and 4.
Yes, sir. That's exactly it.
And then what do I do?
And then once you know your solutions, you just plug them into the general equation you just
Oh,
showed
wait, I
me.
got to find the radians. And then I got to put them on here, you said?
Yes, sir. That's it. We went the longest way possible to get that done. About 2 more minutes and I'll ask somebody to come up and talk us through it. All right, we did take attendance, so that's good. Oh. So guys, real quick, this is going up on YouTube for everyone who's absent. There's this form that I'll publish on Canvas. If you sign it with your parents, you'll be allowed to appear in the video so I can call you up. But that means if you don't do it, you're not immune from being called up. I'll just stop the video and then stitch it back together. So if Nate doesn't do it, I'll just say, Nate, come on up, stop the video. He does his part, turn it back on.
I said no one signs it, so it's going to work for you.
If no one signs it, that's fine. The form I have saying you can appear on the channel just for safety. My bad. Where's your unit? Do you have a unit circle on you, sir?
I just use that unit circle right here.
Ooh. So we want it
It's negative 1/2, right?
for y. It's sine, right?
I went right there.
Double.
I forgot sine's x.
Sine is y.
Wait, I thought we were looking for sine, right?
We are looking for sine. Sine is the y value, so you need when the y is negative half.
When I get,
That's your answer.
I can just leave it. Like,
Well, you're going to put 7 pi over 6 plus 2 pi n. And then n, and then just this part at the end every time. And then you do it again for 11 pi. Sending me a pass? Yeah, go ahead.
I have to put it at the.
Yeah, always put this at the
I
end.
have to put it again.
Yes, sir. Yeah, put the straight line down and then put that in there. And we'll talk more about what it means, but it's going to have it. I'll get you, go ahead and go and finish sending it. Does anybody want to go up and do this one so we can go to the next homework? I saw Destiny's hand first. So Destiny, would you like green, blue, or black?
Or another green. Where's the purple?
I don't know. That's my favorite color up there.
Wait, no, don't you have extra markers?
Somewhere. I would ask my TA that helps me stay.
Is this right?
The only thing you need to add is that n is an element of the integers. But yep, that's it. Yeah, I know. When I was out, a bunch of stuff went missing. I
You
don't.
used to have a whole box of markers.
Oh, I know. Oh, I gave that one to Coach Standhoft. They asked if I had any extras. I'm not. They were free to me, so.
So you got rid of all of the box, like even the colorful ones?
No, I just gave them that one whole box. I don't know where I put the rest. We'll figure it out tomorrow and
Are you
block.
going to the big one too? No, you're not.
All right, Destiny's up there. Please don't talk over her. That'll be extremely disrespectful.
So what we're gonna do here is subtract 1 from both sides. 2 sine x equals -1, then divide by 2. So you're gonna get sine x equals -1/2. So when looking at the unit circle, when you're looking at the sine values, -1/2 falls in the 3rd quadrant and the 4th quadrant. So in quadrant 3, the radians for that is 7 pi over 6. And then in quadrant 4, the radians for that value are 11 pi over 6. So with that being said, when you plug these into your solutions, for your first solution, you're going to have 7 pi over 6 plus 2 pi, which is 1 rotation, times n. What's that element? How do you pronounce that?
N is an element of the integers.
Okay, so n is an element of the integers. Then for your second solution, we're going to have 11 pi over 6 plus 2 pi. N is an element of the integers.
And saying n is an element of the integer stops somebody like me from coming behind and picking the wrong n. You're telling me you have to pick from the integers or you're wrong. You've already messed up.
Do you guys have the line or just like
So that vertical line, is that the one you're asking about?
yeah, can you just like looking so it's your
For now, no, but that vertical line is read such that, so it's a full sentence that way. So yeah, keep the vertical line there. Getting that far today is amazing, so don't feel, yeah, but you would definitely want a vertical line there. No, you don't have to do that anymore. Yep, so I'm trading you off with showing all that extra stuff by just telling me which number system to use. If you don't mind, I'm going to put, Destiny, I don't know if you did the form or not. I'll cut you out if you didn't.
I'll just do it tonight.
Okay, I'm going to post it to Canvas right now. Here's what we'll do.
Is there a form or was it the one that was on its really?
Last quarter, yeah. I'm going to put the form on Canvas right now.
Do we have to redo it if we already did the one?
No, don't redo it. If you want to use the cheat sheet that Peter's going to make, you have to answer the form. There's no penalty for saying no. If Isaiah does not want to appear on the channel, say no so I know, right? That way I'll have a list and say, Isaiah went up, cut him out. If you don't want to go up, there's no penalty for not going up. This is just so I know who it's safe to post.
What if we don't remember?
You can ask, or just do it again. I think I said it's only one, so. I'm posting it right now. And there's no penalty for saying no. Does anybody not want to ever be on the channel? All right, so Nate's hand's up. Nate, there's no penalty. I'm just making a point. There's no penalty whatsoever for saying no. Is anybody still copying that down? If you say no, you still get the cheat sheet. If you say yeah, as long as you fill it out. I just want to know who's safe to post. All right.
Can you divide by square root of 2?
Yeah, why wouldn't you be able to?
Because I can't find it on the unit circle, like 1 over square root of 2. Like negative.
Oh, you have square root of 2 over 2?
No.
What do you? Rationalize this to square root of 2. They're equivalent.
Oh.
If you rationalize the denominator for 1 over square root of 2, you get square root of 2 over 2. They're the same. Yep, remember when I told you to do it? You could pick which one you want. I don't care. I know that they're equivalent. All right. So all of that we just did, if we go back to the unit circle, we can see on the unit circle why it works. And then someone's going to go, well, why don't we just stick to the unit circle? The unit circle is just training wheels for what we're going to be doing later on. Yes, sir?
You said it was 7 right?
Mm-hmm.
Wait, which way are we going? This way or this way?
From this line, it's 30 degrees, so it's this one. Really, Peter, the easiest way?
I
Always
went from here. I went from here.
No, we go in that direction, so the next one would be that one.
Wait.
So we come from this way, hit this,
So
then.
this goes here.
Yep, and then this goes here, this goes here, this goes here. See how they always go into the next quadrant?
So that feels 11.6 will go right here.
11.6 is 30 from.
I mean, 7.6
Yes, sir, 30 from there.
goes right here.
Yep.
And we go over here. But
Yep.
you always move to the next. You never go backwards.
Correct, but then you always check here. Like this is the negative 1/2, so that's our.
Because I got confused. 'Cause I accidentally went here at first.
That's the getting used to it mistake. All right, our first answer was pi over 6, and we said add 2 pi. If I'm here and I go 1 full rotation, that's plus 2 pi. Plus 2 pi. That's what we meant by there's an infinite number of coterminal angles. So we can't use the unit circle anymore, but we can kind of help us make sense of it with it. All right, would we always be able to use this trick, the unit circle, to get our answers? No, why not? Yeah, it feels like Amelia already heard that question get answered. What if I asked you to find 71 degrees? Is that on the unit circle? No. It's not. So guess what we're doing coming up here next class? We're going to do that.